So hi everyone, my name is Shivam Bohra. Welcome to the official channel of CodeChef. So if you want to learn and master data structures and algorithms, or if you want to do really good at competitive programming, then this is a one-stop destination for you. Now before we actually get started, here's a quick reminder for you to hit that subscribe button if you haven't already yet. So welcome to the last video of this series. In this video, we are going to solve a problem called as factory machines, which has a beautiful concept behind it. Now this problem is available on CSS problem set. So you can simply find this problem under the sorting and searching tag, right? So the problem statement over here has been slightly modified to make it a bit easier and simpler to understand. So the problem statement says that we have n machines which takes a1, a2 and so on till an seconds respectively. So which means that we have n number of machines, right? We have 1, 2, 3 and so on till n number of machines, right? The first machine over here will take a1 seconds to make one product, right? The second machine will take a2 seconds to make one product. And the third machine will take a3 seconds to make one product, right? So all these a1, a2, a3 are, and so on are simply the time taken by a machine to make a single product, right? Find minimum time to make t products provided that all machines can work simultaneously. So we have to find the minimum time to make t products. For example, if let's say we have 3 machines and we have to make 7 products, and these are the time taken by these machines to make a single product. So in this case, the minimum time taken to finish 7 products would be 8 seconds. So let's understand how. So the first machine over here, in 3 seconds, this machine will make one product. In 6 seconds, this will make 2 products. In 9 seconds, this will make 3 products. So in 8 seconds, will this make 2.7 products or something? The answer is no. Either it will make one product or not, right? So in 8 seconds, it will make 2 products, right? So in 8 seconds, this first machine is going to contribute for 2 products. The second machine takes 2 seconds to make a product. So 2 seconds for a product. So in 8 seconds, it will make 4 products. The third machine takes 5 seconds for a product. So in 5 seconds, one product. So in 8 seconds, it is not going to produce another product. So in 8 seconds, it is also going to produce just one product, right? So in total, we will have 2 products by first, 4 by second, and 1 by third. So in total, we will have 7 products that are going to be made in 8 seconds, right? So 8 is the minimum time to make 7 products, right? So the constraints here are that the size of this array could be 10 to the power 5, and these array elements and t could be as big as 10 to the power 9, right? But as they say, appearances can be decisive. This is what is going to happen in this particular problem. So firstly, I want you to try this problem on your own. Struggle at least 1 to 1.5 hours before watching the solution. Otherwise, you won't be able to see the beauty of its concept and solution, right? So now let's move on to the approach. So let's say we have 6 products and we have 2 machines, A1 and A2. The time taken by A1 to make a single product is 1, and the time taken by A2 to make a single product is 2 seconds, right? So at 0 seconds, the first machine would not make even a single product, and the second machine would also not make a single product. So at 0 seconds, we will have 0 total products or items, right? At 1 second, the first machine would make 1, the second machine would make 0, and in total we will have 1 product, right? At 2 seconds, the first machine would now make 2 products because 1 product in 1 second. The second would make now a single product, and in total we will have 2 plus 1, 3 products. At 3 seconds we will have 3 products from A1 and 1 product from A2, right? So in total we will have 4. Remember that we have to make a total of 6. At 4 seconds, A1 will now make 4 products because 1 product in 1 second. So in 4 seconds, we will have 4 products. A2 makes 1 product in 2 seconds. So in 4 seconds, it will now make 2 products, right? So 4 plus 2 is 6. So we can see that we have finally got our answer. So our answer would now be 4 seconds because to make 6 products, we need 4 seconds, right? So for this case, 1 and 2, our answer would be 4 seconds. Now we know that we have to start from 0 in this time. We have to start from 0 and we have to go till the total number of products becomes equal to the products that we want to achieve, right? But we really don't know how big this number or this time could be in this loop, right? So let's predict how big this number could be. Now let's understand, in the worst case, what could be the minimum possible time over here. So in the worst case, I will have only one machine. I will have only one machine because the more machines that I have, the faster it would be and the lesser time consuming it would be, right? So to make it more time consuming, I should have lesser or the least amount of machines or the least number of machines. So the least number of machines that I can have, let me correct this. This should be 1. So the least number of machines that I can possibly have is 1. So A1 is the only machine that I have. A1 is also the slowest machine that I can have, right? So the slowest machine over here will take 10 to the power 9 seconds to finish one product, right? So A1 will take 10 to the power 9 seconds to make one product, one product, right? And in the worst case, we can have 10 to the power 9 products. So one product is made in 10 to the power 9 seconds. So 10 to the power 9 products would be made in 10 to the power 9 multiplied with 10 to the power 9, which is 10 to the power 18 seconds, right? So in the worst case, the minimum possible time could be 10 to the power 18, right? Which is extremely huge. So over here, I'm using a loop for this and another loop for this to get the number of products at a particular time, right? Now, this loop 1, in the worst case, it will have 10 to the power 18 iterations. And this loop 2, since the size of this array could be 10 to the power 5, so in the worst case, it can have 10 to the power 5 iterations, right? So 10 to the power 18 multiplied by 10 to the power 5. If we perform this process, then it will take 10 to the power 23 steps to get us the answer, right? Which is extremely larger than 10 to the power 8. It is the worst case or the worst possible number of steps that we can have, right? So we need to come up with a better approach. Now, if I could predict the time over here using binary search, then it would take log base 2 of 10 to the power 18 number of steps, right? Roughly around log base 2 10 to the power 18 number of steps. If I find this, then this should be less than 100, right? So I can convert what could have been 10 to the power 18 number of steps to roughly around 100 steps if I use binary search over here. And we can use this second loop for traversal of this array, which will take 10 to the power 5 steps. So in total, this will take 100 steps. If I use binary search, this will take 10 to the power 5 steps. So we will have 100 multiplied by 10 to the power 5 steps, which is 10 to the power 7, right? So if I use binary search over here, then I'll be able to solve this problem in 10 to the power 7 steps, or roughly around 10 to the power 7 steps. So let's see whether we are able to do so or not. Now let's understand these two cases first with the brute force approach, and then we'll solve them using the binary search. So let's say I want to make two products, right? So at 0 seconds, we will make products. At 1 second, we will make one product. At 2 seconds, we will make three products, right? Now we are supposed to make two, we are making three. So we have no problem. I'll simply write this as the answer for two, right? So I'm making three, but I have to make two. So no worries. This would also be the answer for two, right? So in this case, two would be the answer, even if the total is more than what we are supposed to have. Similarly, let's take another case. We are supposed to make two products again, right? This time, both these machines will make a single product in 2 seconds, right? So at 0 seconds, we will have zero products. At 1 second, we will have zero products. At 2 seconds, both these machines will now make one product each, right? So we will have a total of two product, right? So again, in this case, 2 would be the answer, right? So 2 would be the answer in this case, right? Because 2 is the minimum time to make two products. Also, you can see that at 3 seconds, we also have two products. But since this time 2 is smaller, hence this would be the answer for this case. Now let's see how we are going to tackle these two cases with the binary search approach. Now, firstly, to apply the binary search, I'll create a variable result or time to store the minimum time possible for making two products, and I'll initialize it to -1, right? Then I know that I have to apply a binary search in a range. So my range starts from 0. So this is going to be my low, and my range goes till 10 to the power 18, right? So for now, let's assume that my range is 6, because I know that my answer lies somewhere in between. Then my mid is going to be low plus high divided by 2, right? Low is 0, high is 6. 0 plus 6 over here would be 6. 6 divided by 2 is 3, right? So my mid is going to be 3. So my mid is 3. So this is my mid. Let me erase this. This is my mid. So tell me, after 3 seconds, how many products can I make? I can make two products, right? And 2 is exactly what I want. So I'll change my time from -1 to 3. It means that after 3 seconds, I'm able to make two products, right? Or as of now, the minimum time taken to make two products is 3. But tell me, is 3 the minimum time for making two products or not? The answer is no. Still, the minimum time is 2. So again, I have to search for another 2 in this range, right? So I'll change my high from here till here, right? So for this, I'll set high equals to mid -1 to search in this range. So now what I would do is, again, I'll calculate mid. Low is at 0, high is at 2. So low is at 0, high is at 2. So 0 plus 2 is 2. 2 divided by 2 is 1. So now my mid is 1, right? So now my mid is at 1. So now, after 1 second, how many products can I make? I can make 0 products, right? So this means that I again have to change my range, right? So now I'll set my low to mid plus 1. So let me quickly erase this. And this also. So now my low is mid plus 1. Mid is 1. 1 plus 1 is 2. So now my low will also point at this element 2, right? Now low and high both are 2. So 2 plus 2 divided by 2. 2 and 2 is 4. 4 divided by 2 is 2. So now my mid is also over here, right? Is pointing at this 2. So tell me, after 2 seconds, how many products can I make? I can make two products, right? And 2 is what I want. So again, I'll change my time from 3 to 2. Hence, we can see that I'm getting 2, which is my correct answer, right? Still, the binary search has to end. So now again, my high would be mid minus 1, because this condition is true that we have found our element. So now high would be mid minus 1. Mid is 2. So 2 minus 1 would be 1. So now my high is at here. My high is over here. Let me quickly erase this. My high is over here. My high is over here. And now my low is over here, right? So now my high is smaller than my low. So I should stop, right? And we can see that finally our answer is 2, right? So we got 2 seconds, and 2 is exactly what we want to achieve, right? Now let's see how we are going to apply this binary search in this case, right? So now let's move on to this case. Now, if you remember this case, the answer was this, right? After 2 seconds, we were able to make 3 products, right? But our aim was to make only 2. But there is no 2 over here. Hence, the answer for 3 would also be the answer for 2, right? So if we are able to make more products than what we can make, then this time can also be used as the minimum time for making 2 products, right? So over here, what I would do is, again, I'll initialize my time variable to -1. Again, this 0 would be my low. This 4 would be my high. Mid would be 0 plus 4 divided by 2. So this would be mid, right? Again, at 2, I'm able to make 3 products more than what I am supposed to make, right? So I'll store this time inside my variable time, right? So now my time will change from -1 to 2. Now this is not exactly 2. Still, I'll use this value to get the time for 2, right? If I get more than 2, I'll use this time, right? So now my time is 2. After this, now this will become my high, and let me quickly erase this. So now this will become my high, this will become my high, and this will become my low, right? So now my mid would be 0 plus 1, 0 plus 1 divided by 2, which is 0, if we are taking both these as integers. So now my mid would be over here, right? So this is 0. 0 is less than what we are supposed to have. So I'll change my L, lower limit. So now my low would be mid plus 1. So now low would point over here, right? Let me quickly erase this. So now my low is at 1. Again, we have to find the mid. Mid is high plus low divided by 2. Both are 1. So 1 plus 1 divided by 2. This is mid. It is again 1. So now this is also mid, right? So I'm able to make 1 product after 1 second, right? So again, this is less than what we are supposed to have. So again, what I would do is I'll change my low to mid plus 1, right? And now my low would point to 2, right? This is my low now. As we can see that high is smaller than low. Hence, we will stop over here. And you can see that our answer was 2 seconds, right? Our answer was 2 seconds. So now let's move on to the code. So firstly, I'll initialize low to 0, high to 10 to the power 18, and time to -1. Now all these 3 variables, they can hold values up to 10 to the power 18. So for that, their data type is long. After this, I'll use a loop. So this is the condition for binary search. Low should be less than or equals to high. Then I'll calculate mid. Mid is also long. So to calculate mid, simply do low plus high divided by 2. Since low and high are extremely huge values, so their sum is also going to be extremely huge. So instead of writing low plus high divided by 2, I have written low plus high minus low divided by 2. This would do the exact same thing. Now after this, my total would be 0. Total is supposed to calculate this value, right? This value over here. So initially my total is 0. To get this total, I'll simply iterate through this array, and I'll simply add these values to get this total. So to get this value, simply divide this time with this, right? With the time required by the machine to make a single product. So if you divide total time with the time required by the machine to make a single product, you will get the number of products, right? So simply divide this value by this value, right? So this over here would be nothing but mid, because mid is pointing to all these values. So it would be this value would be mid divided by this value is ARR of I. So ARR of I, right? To get this value, simply divide mid with ARR of I. So over here, I'll use a loop which starts from 0 till the very last element of this array. I'll start from here till here, right? And to get or to add the total, simply divide mid with ARR of I and simply add this to the total, right? Simply add these values, right? And if let's say I have multiple values over here, if let's say I have 3 3 3 3 over here, and I want to make let's say 6 products, right? So in this case, the sum over here would be 12, but after this 3, I need not to even calculate these two, because I know that my work would be done or is sufficient enough at this point, right? So if the total is greater than or equals to the products at any point while iterating through this array, if my total becomes greater than or equals to product, then time would now store mid. Then this value would now be stored in this answer or this time, right? And after this, simply break this loop in the middle or in somewhere in between, where we have found the total to be more than or equals to products, right? After this loop ends, if time was mid. So if time is mid over here, as you can see that if time is mid, it means that we have found a new time, right? We have found a new time over here. So now my high has to be shifted over here. So in this case, high would be mid minus 1, otherwise low would be mid plus 1, right? And after this binary search, I'll simply print time. So that is it for this video. Like if you understood the concept. In case of any doubts or feedback, do leave them in the comment section below. Subscribe to our channel and press the bell icon to get notified about our upcoming uploads. You can also join our Telegram group. The link is in the description, and I'll see you in the next one.